Hi, and welcome to This Is My Architecture. I'm Dave, and I'm here with Tom O'Neill, CTO and co-founder at Periscope Data. Hey, Tom, what do you guys do?
So Periscope is a high-performance analytics platform. We enable data teams to rapidly convert raw data into CEO-ready dashboards using SQL.
Awesome. And there's a couple of steps that you have to go through to be able to do that, right? So maybe start with the ingestion step. Like, how do we get that customer data, and where does it come from?
Yeah, so it always starts with the customer's data, and we mirror that into S3.
Okay.
Once it's there, we load it into our Redshift clusters. And that lets us separate the ingestion phase from the data modeling phase.
And why is that important to analysts?
So analysts want to model the data based on the question they're answering, not based on the data source.
Yeah, I can definitely get that. OK, so now we've got the data in Redshift and copying from S3, very common pattern that we see. What's next?
Yeah, so importantly, the Redshifts are massive, right?
Mm-hmm.
Thousands of nodes, tens of terabytes of RAM across hundreds of clusters. And that enables us to run tens of millions of query per day.
OK, great, awesome. And what generates a query to Redshift when I'm using Periscope data?
Yeah, so anytime someone pivots or filters or drills down, that's a potential query against the Redshift cluster. But we want every Redshift query to be valuable. Mm-hmm. And so we've built a caching layer in front of that experience.
So tell me about the scale of your Redshift cluster. Are we talking, one or two nodes?
Our Redshift clusters are made of thousands of nodes, tens of terabytes of RAM across hundreds of clusters.
Wow, OK, so that's pretty serious. But when your customers are actually using it, you're generating a lot more than tens of millions of queries. How are we avoiding doing too many queries to Redshift?
Yeah, so from the web serving cluster, there's hundreds of millions of query requests coming in from pivots and drill downs and filters. And so we built this cache to detect if we've seen a query before, we can serve the same data back if we know the data hasn't changed.
So SQL can get kind of long. How do you guys store that in the database?
Yeah, so we hash the query to make lookups really, really fast. And then we store the previous results as an encrypted blob.
Great, that's awesome. So if you can avoid a query, it's going to come back much faster from
Absolutely.
cache. And then what is the end result?
The end result is that across the whole organization, folks can have interactive dashboards across billions of rows of data.
That's awesome. Well, thanks for coming out today, Tom.
Thank you for having me.
And thanks for watching This Is My Architecture.